Okay, this question is asking you to draw the monomer used to make PVC. The repeating unit is shown here. And what we see in the repeating unit is two carbon atoms with a bond going in either direction. This means there's a spare electron in each of these carbon atoms and the rest of the formula. Now, it's asked you to draw the monomer used to make the PVC, so you just basically take those electrons and make a bond in here, because this is addition polymerization, and that's your answer there. There isn't really any way to go wrong here as long as you know that you're dealing with polymerization, and the only thing you learn in National 5 is addition polymerization, so you know that there has to be a double bond in your molecule to make your polymer. Right? In your monomer, there must be a double bond to make your polymer. This is addition polymerization. They don't tell you that it's addition, but since you haven't learned any other forms of polymerization, then you probably are going to be happy enough with that question. Right? When PVC is burned, the gas hydrogen chloride is formed. HCl gas. When you dissolve that in water, you get hydrochloric acid. But it contains only two atoms. State that it's a molecule. State the term used to describe a molecule containing only two atoms. Well, it's diatomic. What you must avoid doing here is writing in something like diatomic element. You might have learned about diatomic elements, and there's seven of them in the periodic table you need to know about. So the thing to notice about this question is that you have not been asked how would you describe HCl, the hydrogen chloride gas molecule. You haven't been asked to describe that. Okay, you've just been asked to state the term used to describe a molecule containing only two atoms, right? So you could be just being asked. You're just being asked the generic term, not about this specifically. So if you put in compound, you're going to be wrong, because a molecule containing only two atoms could be a diatomic element, right? And if you put in element, you're going to be wrong, because a molecule containing only two atoms could be a compound, right? Made of more than two elements. So you've just got to watch out for the wording of the question. You haven't been asked to describe this. You've just been asked to state the term. State the term used to describe a molecule containing only two atoms. Okay, that's the trap there. Here's the next question, a table of some data. POM, PET, HDPE, PVC, PP. Now, we don't know what the names of any of these are. It doesn't really matter. What we're being asked to do is draw a graph. And what you must do here is be really careful with these. You get half a box of grace, if you like, leeway on all of these. So you just got to make sure you get it roughly in the right place and draw a good straight line with a ruler. Use a ruler. And then usually, because you have to work in a black or blue pen, quite often you'll be working in a black pen, you've got these black lines on the grid. Just it's always a good idea to just shade in your bars with a pencil or something. You don't have to. The pencil is not part of your answer. It's just shading, so you can use a pencil for that if you want, or use your pen and just put some hatching in there or some chevrons just to show where it is. Now, the most important thing here is just making sure that your scale, you realize what the scale is. So 160 to 180. That means that there's 20 between these two. 20 divided by 5 is 4. So each one of these little squares is worth 4 to you. Okay? So 165 is a little bit above the first 4 line. I'm a little bit off, but you've got half a box, remember? So you've got plus or minus 2 to get that within. So that's going to be close enough. And again, this is 260, so it goes right up to the line. 131. So 4, 8, 2 of those, and 1 extra is, so you're 3/4 of the way into this box, but anywhere within half a box of the correct spot is going to get you the mark. Okay, so you've got a little bit of leeway. It seems like an awkward scale to plot. A little bit over 80 is halfway into one box, and this one here, 130, is going to be exactly halfway between. Okay, the other thing to notice about this graph and drawing it is that you're not plotting points. These are categories and values. So you're plotting a bar chart, and if you just put a point in here and 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 then join them all up or whatever, that would be wrong. This is not a line graph, or you're not plotting individual points. So you got to watch out for that too. You might plot the wrong graph here. It's got to be a bar chart, okay? Category value, category value, category value. There's no relationship between these individual things that anybody's noticed. If, for example, you were plotting the number of carbons in each of these against their melting points, then you could plot a line graph because we'd have a relationship of number against number. But this is not a number, it's a category. Okay. Watch out for making sure you get a nice straight line that doesn't deviate more than a box. If you're going to freehand these, and you're allowed to freehand it, but get a ruler out and make it work. Okay, and finally, this one can cause a few problems because you just don't know how to write the answer. Suggests why PVC could not be used as a container for boiling water. It hasn't asked you to give a reason for this. So you haven't been asked to use, you need to use the data. Okay, so PVC's melting point is 82 degrees Celsius. Right, so it's going to melt if you put it in boiling water. And that's all you have to say. It would melt. That'll get you the mark. It would melt.